Another type of graph that is very commonly used and with which we will work a lot is the so-called scatter plot. Scatter plot plots against each other the values of cases or units of analysis on two variables simultaneously. So it is something like the combined bar chart which we have already seen today, but for continuous rather than categorical variables. These values are captured by the positions of dots or circles or rectangles in a two-dimensional space, so put very simply, in a standard graph. We start with R now. Well, I think you will love to see that to create a scatter plot in R, all you need to type is the command plot with the two variables you want to plot in brackets. So let us say we want to plot against each other polity as a measure of country democracy, or on the horizontal axis, and HDI as a measure of development on the vertical axis. To do that, we simply type into the brackets after the plot command first exporters and $sign polity, and after comma exporters $sign and HDI. Again, the prefix exporters with the $sign indicates the dataset from which the variables come. Here is our first scatter plot. We can again give the graph a title and perhaps even labels for the x and y axis using the options main, setting it equal to some string, and xlab and ylab respectively. We can also change the colors of the dots if we really want. So let us improve the graph a bit in this way. And here we are, polity, HDI, title, and the dots have a different color. In fact, there are other options we can specify, and I encourage you to play with them. So for instance, we can change the shape of the data points as well as their size. You should feel free to look up online what specifically these options actually mean. And here we are, we have changed the graph. Now, in Excel, creating a scatter plot is also quite easy. Under the Insert ribbon and Chart, select Scatter Plot. Then we go for Select Data and for Add, here, Data Series. And we fill out the relevant vectors of data from the dataset. So first, the X values, the polity scores. So we start here with United Arab Emirates. And we want to go down to line 47, as we know that there are 46 cases in our dataset plus the first line with variable names. For the Y values, we want the scatter plot to plot the values of Human Development Index. So let's do the same. Colon, and again, we are going up until point E47. We can also give the graph some name. So for instance, simply HDI. And here we are. Here is our scatter plot in in Excel. Once we create the graph, we can play with all kinds of menus to adjust the graph. Now, what may actually be cooler than simple scatter plots are the so-called bubble charts, in which the size of the dots actually corresponds to the values of some third variable. For example, we want to see in the plot not only the individual countries' Human Development Index and polity scores, but we want the point size to reflect the size of the country's populations. To create such a graph, go for Insert again, but here select Bubble Chart rather than Scatter Plot. Fill out everything as previously. So here we will have HDI for series name. For x values, we will have polity scores up until line 47. For y values, we will use Human Development Index, again up until line 47. But in addition, fill out the last cell in the menu with the values of the country's populations, again up until line 47. As you can see, the size of the bubbles indeed changes to reflect the size of the country's populations. The largest bubbles will be the undemocratic China in the left, low on the polity score, India in the right with somewhat lower HDI than China actually, and the US close to the top on both democracy and HDI, Human Development Index. This, I believe, is a nice type of graph in that it effectively allows us to depict three variables or information contained in three different variables on a simple two-dimensional plot. Now going back to R, we could actually achieve the same result using a command called symbols instead of plot. In the brackets, we specify the same two variables as in scatterplot, but in addition, we provide one option called circles, which we set equal to the variable we want to capture with the size of the bubbles. Now, the problem is that just setting circles equal to exporter's $sign population would make the large bubbles way too big and the small ones way too small, as this command, called symbols, adjusts the bubble's radius and not the area, and we want the area to reflect the size of the populations. So to make the bubbles correspond to the population with their area rather than radius, we need to divide the size of the population here in this formula by the constant p or pi. Remember, 3.14, etc., up until infinity. Moreover, we need to take the square root of the whole thing. So sqrt for square root of this component within the bracket. To see why we do this, recall your high school geometry classes, where you learned that the area of a circle is the square of its radius multiplied by the constant pi. Here we are trying to get the opposite, so to use population size to determine the area of the circle rather than its radius. Hence, we are dividing by pi instead of multiplying by it, and we are taking the square root of this component rather than the square. So use the line of code provided to do this. We can also specify the option BG and set it equal to red to make the circles red. So let us run the piece of code. Beautiful, isn't it?